In this lecture, we are going to determine the project duration and critical path of this project that we were given the table of dependencies for. So we're going to draw a rough diagram over here and make sure we don't have any unnecessary crossovers. We will redraw it all nice and pretty and with space to put more information on our notes. And then we'll do a forward pass and a backward pass to get the early start, late start, and all that good stuff that we can find at the critical path, and also the whole project duration. So first thing first, let's do a rough draft here. We know that activity A is the first activity in the project because it has no predecessor. So we'll go ahead and draw that. Activities B and C both depends on activity A. So we can write activity B and activity C. Next up, we have activity D. This depends on activity B. So we have activity D. Now activities E and F both depend on activity C. So both of these guys are going to come off the activity C. So we have activity E and we have activity F. Next up, we have activity G. This depends on D and E. So we're going to need some arrows coming up both of these guys leading into activity G. And lastly, and that depends on activity F and G. So we're going to have H there and F is going to lead into it and so is G, and there we go. So starting with activity A, we start at 0. Activity A, its duration is 3 days. So we have 0 plus 3, its early finish will be 3. Remember, what we do is, we bring the late or the early finish into the early start of these activities B and C. So we just bring the 3 up because they can't start. Activity A is done. So again, now for activity B, he's a 3 plus 4, 7. Activity C, 3 plus 2 is 5. You can really go in any order that you want here, just as long as you make sure you're bringing over the right number. So we're going to bring 7 into activities D early start, and 7 plus 5 is 12. Now we can't fill in for activity G yet because there's 2 different arrows coming in from activity D and E, and we'll have to pick the larger value. E, we have 5 as ES here, so we are going to bring the 5 up. 5 plus 1 is 6. Obviously, the 12 here will win for activity G's early start, right? Because activity G depends on activity E and D. It can't start until D and E are both done. And while activity E finishes on the end of day 6 here, and D finishes on the end of day 12. So obviously, we have to wait till the end of day 12 before we can start activity. So we bring in the 12 as early start for activity G and add duration of activity G, which is 4. It will get you 16. Now again, we have to wait for filling out the value for activity H. We're not sure we can put because there's 2 arrows coming in from activity G and F. So we have to go all the way back to activity C. So we had the early finish on C. We are going to bring that into early start of F. That's 5 plus 2 is 7, and what we are going to bring here, we have a 7. So for activity F, its EF is 7. And at activity G, we have a EF of 16. Well, the 16 obviously wins because activity H depends on G and F. And obviously we can't start it on day 7 or at the end of day 7 or beginning of day 8 because we need to wait for activity G to finish. Activity G is expected to finish on or at 16 to bring that 16 in, and we'll have 16 plus 3 is 19 for activity H. So right away, we know that the duration of the project, the planned duration of the project is 19 days. Now we want to find out the critical path. So we're going to have to do the backward pass. How we do that is you start by taking 19 and bringing it down here as LF for the activity H. And at this time around, start subtracting the duration as we go back. So we have 19 minus 3, we get 16 as LS for activity H. Now we can bring the 16 as LF for activity G, and we can also bring it as LF for activity F because there's no competing arrows in. So first of all, for activity G here, 16 minus 4 as LS for activity we have 12. And again, we can bring this 12 as LF for activity D and E because there are no arrows leading in. There's only one. So at activity 12 minus 1 is 11, and activity D we have 12 minus 5 is 7 as LS respectively. Again, for activity F we have LF as 16. LS for activity F will be 16 minus 2 will get 14. 2 will get 14. For activity B, we have only one arrow being led by activity D. So LF for activity B will be the LS of activity D, which is 12 minus 5 equals 7. Situation at activity arrows being led from activity E and F. Remember, with the backward pass, we do the opposite of the forward pass. So we bring the smaller number of the two as LF. At activity E, we have 12 minus 1 equals 11. And at activity F, we have 6. So we will choose 11 as LF for activity C. So LS for activity C will be 11 minus 2 equals 9. We have another interesting situation at activity A because again, two arrows are being led from activity B and C. Activity B has an LS value of 3, while LS of activity C is 9. The lesser value wins. That is, we will put the value of 3 that is being led by activity B. LF value for activity A will be 3 minus 3. A will be 3 minus 3 equals 0. This will be the LS for activity A. To identify the critical path, all we have to do is figure out which activities have their early finish and late finish being the same. So we have activity A. Here the early finish and late finish are both 3. Activity B, the early finish and late finish is 7. Activity D, it's 12. Activity G, 16. Activity H, 19. So B, D, G, H would form critical paths. This also means that if we delayed any one of these activities by any amount of time, even if it was just a day, the entire duration of the project would actually increase by that day. Whereas if you look down, it may be activity C, activity F. We can actually delay some of these activities for actually quite some time. So let's learn how to calculate free float and total float, also known as free slack and total slack. The words float and slack are interchangeable. They mean the same thing, but total float is different from free float. So in this lecture, you already know how to draw the PDM network diagram for this. Let's calculate the total float of each activity. We'll write that above each node. If you recall from the previous lectures, we can find the total float by subtracting the early finish from late finish, or early start from the late start. For all the activities falling on the critical path, the value of total float will be 0, as we have already maintained in our previous lecture. But you're free to calculate it, and you will find the total float values of all the activities on the critical path to be 0. That leaves us with 3 activities: activities C, E, and activity F. Calculating for their respective total float values, we find that for activity C, the total float is 6. Activities E total float is 6, whereas the total float value for activity F is 11. The last thing to do is calculating for the free float of each activity, and we'll write the free float in the blank middle box of the third row of each activity. The start of all the successors of a given activity minus the early start of the given activity minus the given activity's duration. So for example, for activity A, the minimum early start of all its successors, we have 2 options. We have 3, or we have 3. So we have to pick 3. So 3 minus 0 minus 3, which is the duration, its free float is going to be 0. Another thing to notice is the free float is always equal to or less than the total. It can never be more than the total float. So right away, if you are on critical path, you know that free float will always definitely be 0 for all of these. But I'll just show you a few examples just to prove that. For example, for calculating activity B's free float, we would take the earliest start of its successor. So that would be 7 minus its own early start, its own duration. So 7 minus 3 minus 4, that gives us 0. Same thing goes for activity D. We would have 12 minus 7 minus 5, that gives us 0. And the free float of activity G, we would have 16 minus 12 minus 4, that's 0. Let's not forget activity H. It doesn't have any successor, but its total float is 0. So its free float can be greater than 0. So its free float is also 0. So let's look at these guys now that aren't on the critical path. So activity C, it has 2 successors. So we have to choose the smallest successor. And it just turns out again that they both have the same early start of 5. So then we must subtract. We have 5 minus 3 minus 2. We have the activity C free float equal to 0. Now for activity E, take 12 minus 5 minus 1. So it has a free float of 6. And then for activity F, we can go 16 minus 5 minus 2, and we'll get a free float of 9. If you recall, total float was the amount of time any given activity can be delayed without affecting the end date of the project. For example, anything on the critical path. Have you delayed by anything? Even if you delayed one of these activities just by 1 day, you would extend the entire duration of the project by 1 day. If we increased any of the activities that are not on critical path, for example, activity E, we have 6 days, which implies we can delay this by up to 6 days and still there will be no impact on the overall duration of the project or the critical path. So this will be the end of this lecture. I hope your time was well spent and you have learned a very important topic for your exam today. Expect 3 to 5 questions on critical paths in your exam.